the clock in the sky, and the secret of the blue dot. There are moments when we find ourselves standing in an unfamiliar city street. We thought we knew the way, but at some point every alley begins to look the same, the signs become unfamiliar, and our sense of direction slowly fades. Then we take out our smartphone. We open the map app, and there, at the center of the screen, we see a small blue dot. That dot quietly says, "You are here." It is a strange thing. My smartphone knows where I am before I do. When I am lost, this small device in the palm of my hand tells me my current location, almost like an eye in the sky looking down at me. But how does a smartphone know where I am? We could simply say because it has GPS. But if we look just a little deeper, this question becomes much more than a technical explanation. Hidden inside that blue dot are satellites, atomic clocks, the speed of light, Einstein's theory of relativity, cell towers, Wi-Fi signals, and one of the oldest questions human beings have ever asked: where am I? In fact, this question did not suddenly appear in the age of smartphones. Human beings have always wanted to know their place. Sailors at sea looked up at the stars. Nomads in the desert read the sun and the wind. Travelers in the mountains remembered ridges, rivers, and valleys. The North Star was not just a star. For people who had lost their way, it was a coordinate written in the sky. Today, instead of looking up at the stars, we look down at our smartphones. But the essence has not changed very much. We are still beings who want to know where we are in the universe. What has changed is this: the stars have entered our pockets. The blue dot on your smartphone is not just a location marker. It is the modern person's small North Star. Many people imagine GPS like this. My smartphone sends a signal to a satellite and asks, "Where am I?" Then the satellite answers. It sounds as if the phone is speaking to the sky. "Please tell me where I am." But the basic mechanism of GPS is different. In ordinary GPS positioning, your smartphone does not ask the satellites a question. Instead, it mainly listens. High above Earth, GPS satellites continuously broadcast signals. Inside those signals are two crucial pieces of information. First, where the satellite itself is located. Second, exactly when that signal was sent. Your smartphone receives these signals and calculates: how long did it take for the signal to leave the satellite and arrive at my phone? Radio waves travel at the speed of light. So if the phone can measure the time delay, it can estimate the distance. Time becomes distance. And here we encounter the beautiful reversal at the heart of GPS. Your smartphone is not asking the sky a question. It is interpreting a broadcast of time coming down from the sky. So how is location determined? Imagine that you know you are a certain distance away from one satellite. That means you are somewhere on the surface of a huge sphere centered on that satellite. But that is not enough. There are still too many possible locations. Now add a second satellite. The possible locations become narrower. The two distance conditions overlap. Add a third satellite, and the region narrows even more. A fourth satellite is also important because it helps correct the clock error inside the smartphone. People often call this triangulation, but more accurately, it is closer to trilateration. The phone is not measuring angles. It is finding the point where several distance measurements intersect. Your location is not an answer that simply falls from the sky. It is calculated as multiple pieces of distance information overlap, intersect, and correct one another. On the map, we see one small blue dot. But behind that dot are time signals from several satellites, the meeting point of clocks in the sky. That is what we call my current location. And here, we need to notice something very important. GPS looks like a technology of position, but at its deepest level, it is a technology of time. Distance comes from time. If we know the difference between when a signal was sent and when it was received, and then multiply that time by the speed of light, we get distance. So for GPS to be accurate, time must be accurate before location can be accurate. Even an extremely tiny time error becomes a large location error. Light travels about 300,000 kilometers in 1 second. So even a millionth or a billionth of a second matters. A time difference far shorter than the blink of an eye can become tens or hundreds of meters on a map. That is why GPS satellites carry extremely precise atomic clocks. We think we are finding our position. But in reality, our smartphone is listening to time. It does not touch space directly. It reads differences in time. Location is, in a sense, a translation of time. And this brings us to a truly surprising fact. Every time we open a map app on our smartphone, we are using Einstein's theory of relativity. When we hear relativity, we usually imagine space, black holes, the speed of light, or time travel. But relativity is not only a story about the distant universe. It is working even when we find our way home. GPS satellites move rapidly around Earth. A clock that moves quickly flows differently from a clock on the ground. This is an effect of special relativity. At the same time, GPS satellites are far above Earth's surface. They are in a region where Earth's gravity is weaker than it is on the ground. Where gravity is different, the flow of time is also different. This is an effect of general relativity. In other words, the clock on a satellite and the clock on the ground do not naturally stay perfectly synchronized. That difference may seem tiny, but in GPS it is critical. If time is wrong, the distance calculation becomes wrong. If the distance calculation is wrong, the location becomes wrong. That is why the GPS system requires relativistic corrections. Think about how astonishing this is. Einstein's equations are not only written on blackboards, they are not only abstract symbols inside scientific papers. At the very moment you call a taxi, find a route, or walk toward a meeting place, relativity is quietly operating inside your smartphone. The theory of relativity is a theory about the mysteries of the universe, but it is also the hidden engine of everyday navigation. And yet, smartphone location is not always perfect. When we enter a building, the blue dot may begin to drift. Inside a subway station, it may point to the wrong place. Between tall buildings, the map may say we are on the opposite side of the road. Why does this happen? GPS signals are very weak radio signals, traveling all the way from satellites to Earth. They can be blocked by walls. They can bounce off tall buildings. They may barely reach underground spaces. In such environments, the smartphone has difficulty reading the satellite signals accurately. A dense urban area full of skyscrapers is, in a way, a maze of signals. The signal may not come directly from the satellite. It may bounce off glass or concrete before reaching the phone. The smartphone receives it, but the signal may have travelled a longer path than expected. Then the distance calculation becomes distorted. At this point, we need to rethink the nature of the blue dot. The blue dot on the map is not an absolute truth. It is the most plausible estimate calculated from incomplete signals. We look at the blue dot as if it were certainty. But in reality, it is the result of probability. Satellite signals, cell tower information, Wi-Fi, sensor data, all of these are combined to produce the most likely location. So does your smartphone know where you are only through GPS? No. A modern smartphone uses many senses, almost like a small living organism. GPS is the sense of the sky. It listens to signals from satellites. Wi-Fi is the trace of surrounding buildings. By checking which Wi-Fi access points are nearby and how strong their signals are, the phone can estimate its location. Cell towers are the pulse of the city. By knowing which tower your phone is connected to and how surrounding tower signals are received, the phone can estimate your approximate position. The accelerometer senses whether you are moving. The gyroscope detects changes in direction. The barometer can help estimate altitude or even floor level in some situations. All of this information is fused together. A smartphone does not see you with one eye. It finds you by reading the sky, the city, and the movement of your body together. This resembles human perception. We do not understand the world with our eyes alone. We hear sound with our ears, feel wind on our skin, sense balance through our body, and remember paths from the past. A smartphone does something similar. It combines satellites, Wi-Fi, cell towers, sensors, map data, and movement patterns. And from that combination, a small blue dot appears on the map. That blue dot is not just a dot. It is the result of the sky, the city, and the movement of your body meeting in one place. Now we can ask a more philosophical question. Am I really a single point? On a map, I appear as a small blue dot. The dot is simple and clear. But the real I is not a point. I am someone who left home. I am someone walking toward an appointment. I am someone with memories. Someone going to meet another person. Someone who chose this path for a reason. Even scientifically, my position on a map is not an isolated point. It is the result of relationships among satellite time, Earth's gravity, the speed of light, smartphone sensors, nearby Wi-Fi, and the cell towers of the city. My location is not determined by me alone. It is determined through relationships. This resembles the way we exist as human beings. We do not live as isolated points. We discover ourselves in relationships with family, in conversations with friends, in the streets of our city, and in the places held by memory. Perhaps a human location is not just an address. The question, where am I, may also mean, what am I connected to? On the map, I appear as one point. But in reality, that point is where countless relationships meet. But location technology has another face. It is convenient that a smartphone knows where we are. It helps us avoid getting lost. It lets us call a taxi. It lets us receive deliveries. It helps families check one another's safety. In emergencies, it can even help rescue teams find us. But knowing someone's location does not only mean knowing their coordinates. It may also mean knowing where they often go, when they move, whom they might be meeting, and what patterns shape their daily life. Location data is the trajectory of a life. That is why modern location technology has two faces. One face is a kind guide that helps a lost person find direction. The other face is the possibility of recording a person's movements. Technology has always been this way. Fire gave warmth to human beings, but it also gave destructive power. Writing preserved wisdom, but it also became a record of power. Location technology makes us safer, but it also leaves traces behind us. So we should not look only at convenience. We need to know which apps use our location, whether they truly need precise location or only approximate location, and how location history is managed. There is no need to fear technology, but we must understand how technology reads us. A technology that finds me should not become a technology that owns me. Now let us take one step deeper in the ThothSaem style. How might we interpret location from an IG perspective? Of course, in standard science, smartphone location is explained through satellite signals, time differences, radio waves, and sensor fusion. That explanation is already powerful and forms the real foundation of the technology. But from an IG perspective, we can add one more question. Is location really a fixed point already embedded in space? Or is it an event that appears through relationships among information? In GPS, location is not an independent absolute point. It is calculated only when satellite time, signal paths, the receiving state of the smartphone, Earth's gravitational field, and the chosen coordinate system all fit together. So the statement, "I am here," is not a simple declaration. It means that many pieces of information have become mutually consistent. From an IG perspective, location can be seen not as an address owned by an object alone, but as a coordinate event that appears when information becomes aligned. The satellites in the sky send time. The city sends signals. The smartphone records movement. The map provides spatial structure. And when all of these pieces of information converge into one point, we say, "I am here." This is a fascinating interpretation. We usually think of location as a problem of space, but GPS shows that location is also a problem of time. It also shows that location is a problem of relationships. And at a deeper level, location is a problem of informational consistency. Which coordinate is true? For a coordinate to be true, the signals must agree without contradiction. Satellite time and smartphone time, signal speed and distance, map data and sensor data must not conflict with one another. When information becomes consistent, location appears. When information becomes inconsistent, location begins to drift. When the blue dot jumps around in a city full of skyscrapers, it is not merely a technical error. It is a state in which the information has not fully reached agreement. The signal from the sky, the reflected signal, the structure of the city, and the sensors inside the phone are telling slightly different stories, and so the location trembles. In this sense, location is not a fixed point. It is an informational agreement, and this too resembles human life. We often think of ourselves as fixed beings, but in reality, we confirm ourselves through many relationships. In someone's memory, in the way our family calls our name, in the roles society gives us, in the time we have walked through. That is how the coordinate called I is formed. To lose one's location is not only to lose one's way. It can also mean losing the sense of who I am, where I am going, and what I am connected to. That is why the blue dot on a smartphone can offer a strange kind of comfort. You are here. Those words are not only coordinates. Sometimes they are a small reassurance for modern people. In a complex city, among countless signals and people, it tells us that we have not disappeared. But we must also remember this. A smartphone tells us our physical position. It does not tell us the direction of our life. A map can show the fastest route to a destination, but it cannot tell us why we should go there. Navigation can tell us when to turn left or right, but it cannot decide the turning points of our lives. Technology shows the road. Meaning must still be chosen by human beings. Ancient people looked at the stars to find their way. For them, the stars were not just celestial objects. They were an order written in the sky, a calendar of seasons, and a map of myth and memory. Today we look at smartphones. At first glance, it may seem as if the romance has disappeared. Instead of looking up at the night sky, we look down at a small screen, but we can see it differently. We have not lost the stars, we have put the stars into our pockets. Inside the small map on your smartphone are satellites in the sky. There is the precise time of atomic clocks. There are the speed of light and the gravity of Earth. There is Einstein's theory of relativity. There are the Wi-Fi signals and cell towers of the city. And there are the traces of your own footsteps. When we follow the blue dot, we are not simply moving toward a destination. We are confirming our place on a coordinate system made together by clocks in the sky and signals on the ground. So the next time you open your smartphone map, pause for a moment and think about it. That small blue dot is not just a dot. It is where satellite time, Earth's gravity, the speed of light, urban signals, and your own movement meet. Your smartphone does not know your location all by itself. The sky, The city and time together tell you where you are right now. And perhaps the deepest message science gives us is this. I am not an isolated point. I am a being who receives location through relationships. Between sky and earth, time and signal, memory and road, I finally become here. When we are lost, we look at our smartphone. But when we are lost in the larger paths of life, we must ask again, where am I? Where am I going? What am I connected to? The blue dot on a smartphone tells us our current position. But what kind of story we create by following that dot is still left to us. We live in an age where the stars are in our pockets. Now the important question is this. Where will we walk guided by that starlight? This is ThothSaem Physics.